especially to our lecturer, Madam Nurul Huda binti Ismail. So the first thing is I'm gonna introduce myself. My name is Junitana Janice, and I will introduce also my team member. The first one is Muhammad Azlan bin Roslan. The second one is Muhammad Shami bin Asmi. The third one is Normisha Stafia binti Muhammad Arif, and the last one is Nur Shafiqah binti Ali Sabri. I will proceed, and we are from group 7. I will proceed to the introduction. So, as we can see that in this assignment, we apply the knowledge that we have learned in the subject of digital signal processing. So in this assignment we applied the chapter 5, which is the Z transform, and chapter 6, the digital filter. So what is Z transform? So Z transform is a mathematical process that converts discrete time domain into the Z domain, which we also call it as a frequency domain. So in discrete time domain, a signal is usually defined as a sequence of real or complex numbers, which is then converted to Z domain by the process of Z transform. So for the sake of analyzing the continuous time linear variant LTI system in this project, the Laplace transform is utilized. So to analyze the discrete time LTI system, the Z transform is also applied. So in this assignment, we apply the formula as below to convert the discrete time signal xn to xz. So as you can see here, is xn is the discrete time signal, while xz is the Z transform of the discrete time signal. So Z transform consists of two parts. So the first part is the formula stated just now, and the second part is to define region of convergence for the Z transform. So Z transform, as you can see, it is summations. So for the summations to exist, it needs to converge at some point. So I will proceed to the finite impulse response. So finite impulse response (FIR) is included to solve the task in this project. There are many types of filter for the finite impulse response (FIR). The first one is LPF. LPF is low pass filter. It is used to eliminate the high frequency, as it only allows only one frequency signal to go through to its output. It is used, in other terms, to control the highest range of frequency in the audio signal. The next one is HPF. HPF is high pass filter. It rejects only frequency components below some threshold, or it eliminates low frequency. The next one you can see here is BPF. BPF is band pause filter. It limits the bandwidth of the output signal to the minimum amount needed to transmit the data. It also allows for selected frequency to be decoded and eliminate the unwanted frequency from transmitting. The last one is BSF. BSF is band stop filter. It screens out the frequencies that are within a certain range, giving easy passage only the frequency outside of that range. So right now I will present to you about our objective for this assignment. So the first one is to apply the theory that have been learned from the subject of digital signal processing that can be related to the system. The second one is to enhance the skill using software like MATLAB and Microsoft Excel. as in this project we use these two software. So the next one is to calculate the coefficients value of transfer functions and frequency response using coding and FDA tool functions in MATLAB software. And the next one is we can see we can design and stimulate the coding of infinite impulse response IIR by using MATLAB software. And the last one, we can able to demonstrate the simulations using MATLAB software for filtering any noise signal at the output. So that's all from me. I will pass it to the next team member.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syafiqah binti Ali Sabri. My metric number is AE1800074 and I'm going to present for the methodology part. The first one is the tools. We are using two tools, which is the first one is Microsoft Excel as our main simulation tools, and the second one is MATLAB to double confirm our result on Microsoft Excel. For the second one, the method. Firstly, we must understand the discrete Fourier transform theory for complete the task, which is the calculation. And second one, we need to get used to the simulations working. For the Excel, we need to know how to insert the equation, and for MATLAB, we need to know how to do the coding. For the third one, we must done the manual calculation first, and then we do the coding and run the simulation, and finally we analyze our result and proceed with the discussion. And this is the flowchart of our process, which is the first one. We need to start and discuss all the tasks to distribute among group members. For this stage, we are doing the Google Meet, and then we find out the perfect solution to solve the question given, which is using two ways. The first one is create the manual calculation, and the second one is build the coding on Excel and MATLAB. For the manual calculation, we proceed with the output signal of HZ filter system and its spectrum, and when we get the result, is it the right result and solution we want, and if yes, we do the result analysis, but if no, we create the manual calculation again and then we end. For the MATLAB and Excel, we run the simulation and then we obtain the right result or not. If no, we must do the coding again, and if yes, we end the session. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syami bin Azmi. So today I want to explain about the project of digital signal processing. So this is the data that we gain from the URL that given. So after we apply the discrete Fourier transform here and we apply the identity, so we get the new formula for the XDFT. Okay, so after that we go to the Excel and then we can calculate the real and imaginary. So after we have the value of real and imaginary, we can get the value of magnitude and value of phase. So the result analysis for the question 1. For question 1, the first graph was obtained from the data that has been given in a table. So the second graph is the magnitude spectrum signal from the first graph. Okay, so both of the spectrum signal were obtained using Z transform. Finally, the lowest frequency component was obtained from the magnitude spectrum signal graph by observing the first bit x-axis. So that's all for my explanation. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azlan. My metric number is CE1800011. Okay, for the result analysis for the question 2, okay, we do the manual calculation. Like you can see this in this slide, we do the Z inverse transform manual calculation. Okay, in question we must apply the filter to the signal from the previous question. We must do the Z inverse transform on HZ and G7 in order to answer this question. After that, we must apply the convolution method to the baud signal in order to generate a new filtered signal. Okay, in this case we use two methods. First method we use the Microsoft Excel, and then the second method we also use the MATLAB to compare the answer with the same. Okay, let's see the Excel first. As you can see, this is the Excel that we built. Okay, and then we take the data from the G7. Okay, the convolution approach can be utilized in Microsoft Excel by multiplying baud signal with the formula G7 and H. However, there is a rule to follow in order to complete if we select a value from the G7. Okay, in the first row, we must multiply it by the value of Hn in the last row of the finding n. Meanwhile, in MATLAB we also added another coding. Okay, in this section, since I want to see how many time the delay and reach the peak, finally we need to determine the Z inverse transform and the convolution method based on the result of the manual computation. Okay, this coding that we built. Okay, we apply the filter and then we run. We can get the same signal. Okay, then for the value of yn still same like the MATLAB. Okay, you can see that the graph is still the same like the Excel. So that's all for me.
Hi, my name is Nurmisha Safatul Ma'arif. So for the question 3, question 3 states that to estimate the spectrum of the filtered signal in question 2, we will do a coding for the question 3 using MATLAB. This is the coding of the spectrum of filtered signal using the Z transform. From the coding below, we get the signal of the filtered signal, the filtered magnetic spectrum signal of the Z transform, and lastly the filtered phase spectrum of signal of Z transform. We can see the signal in the figure below. Question 4. Based on your result, identify the types of filter used. This question asks us to identify the types of filter used. To identify the types of filter used, we compare the signal graph from question 1 and question 3. Based on the graph signal in figure above, there's two signals. We use the infinite input response IIR filter because of this signal filter is designed to generate an infinite impulse response of a dynamic system. The IIR filter are used for a system that can generate an infinite response. The IIR filter I use the delayed version of the input signal and feedback, also a delayed version of the output signal to filter the input to the output. This filter operates an indefinite period of time.